cybernetic analysis of malware behavior using machine learning in artificial intelligence digital platforms. From a historical perspective, malicious software, which is also known as malware, possess a major threat to the security of all computer systems in artificial intelligence digital platforms. There is a diversity of variants render classic security defenses pretty much ineffective. As a result, millions of hosts in the internet are infected with malware in the form of computer viruses, internet worms, and Trojan horses. In this particular application, I use obfuscation techniques such as binary packets, encryption, or self-modifying code to obstruct analysis. These techniques are especially effective against static analysis of malicious binaries. The framework used for automatic analysis of malware behavior using clustering and classification includes scalable clustering and classification, incremental analysis of malware behavior, extensive evaluation with real malware. In the case of scalable clustering and classification, we use a proposed mapping of monitored behavior to a vector space such that behavioral patterns are efficiently accessible to means of machine learning. To attain scalable computation with thousands of vectors, I introduce an approximation using prototype vectors, which is also applicable to clustering as well as classification techniques. The main objective in the theoretical background is to provide essentials to understand the malware detection and the need for machine learning methodology. The malware types relevant to the study are described first, followed by the standards malware detection methods. After that, based on the knowledge gained, the need for machine learning is presented along with the engineering software developed models. So we'll talk about the detection methods. That is, all malware detection techniques are divided into signature-based and behavior-based methodology. So it is essential to understand the basics of two malware analysis approaches, that is, static and dynamic malware analysis. So simply, from the name, static analysis is performed statically without execution of the file. That is in contrast with dynamic analysis, which is conducted on the file while it is being executed, such as in the case of a virtual machine. Static analysis is viewed as reading the source code of the malware and trying to infer the behavioral properties of the file. As a result, static analysis includes various techniques. File format inspection, which is file metadata that provides useful information. and can provide much information on the compile time, imported and exported functions, etc. The string extraction refers to the examination of the software output, such as status error messages, and inferring information about the malware operation. Also included is fingerprinting, which includes cryptographic hash computation, finding the environmental artifacts such as hard-coded username, file name, register strings, and finally AV scanning. If the inspected file is a well-known malware, most likely all antivirus scanners will be able to detect it, although it might seem irrelevant. This way of detection is used by AV sandboxes to confirm the results. On the other hand, disassembly refers to reversing the machine code to assembly language and inferring the software logic and intentions. The static analysis often relies on various tools. Beyond the simple analysis, they can provide information on protection techniques used by malware. Malware detection using machine learning and developing detection systems based on modified perceptron algorithms. These mathematical algorithms are a subclass of the artificial intelligence design methodology, where the main idea is the ability of the system, that is, the programs and algorithms, to learn from its own actions. Therefore, the main idea of the machine learning task is to train the model based on a used algorithm and perform a certain task, such as classification, clusterization, regression, and many others. The training is done based on the input data set, and the model that is built is used to make different predictions. So the output of such model depends on the initial task and the implementation. The machine learning task, as it is applied in this specific project, consists of 5 stages. Data intake. At first, the data set is loaded from the file and is saved in memory, followed by data transformation, which at this point the data that was loaded is transformed, cleared, and normalized to be suitable for the algorithm. Data is converted so that it lies in the same range and it has the same format. At this point, feature extraction and selection are further performed. Third, model training is a model which is built using the selected algorithm, followed by model testing. The model that was built or trained during step 3 is used using the test data set, and the produced result is used for building the new model. And finally, step 5, the model deployment, which is the best model is selected after the defined number of iterations or as soon as the needed result is achieved. Support vector machines is another machine learning algorithm that is used for classification issues. So the main idea is based on finding such a hyperplane that would separate the classes. The term support vectors refers to the points lying closest to the hyperplane that would change the hyperplane position if removed. So the distance between the support vector and the hyperplane is referred to as margin.